I will begin with a word of prayer. Dear Heavenly Father, we thank you for this day. Again, thank you for these students. Just ask you to just guide our thoughts today. Help us to prepare for the test. Help the students ask questions that they have about the test. And I just pray that you be glorified in what we do this week, Lord. In your name I pray. Amen. All right, so everybody top hat? All right, so let me try to focus my attention today on the things people tended to get wrong. Of course, if there are any questions, feel free to ask. We have, today is mostly for your questions. If you don't have questions, then I'll just talk about, things I saw wrong in the grading. But certainly, if you have a question about the test Wednesday, feel free to ask. Nobody? Yeah.
I don't believe they're coming back.
Ah. What was your question in the back? There's a question. I think the test. I'm probably gonna make the test slightly shorter, because a lot of people didn't quite finish. But I actually don't think the quiz was too long, honestly. But one of the other sections begged me to make it shorter, so I'll make it shorter. Mostly to show them it wasn't about the length, it was because they didn't know how to do certain problems. And if you know how to do certain problems, it'll eat all your time. What's your name?
Travis.
Okay, gotcha. Uh-huh. So, but yeah, I think the test probably be a little bit shorter. Okay, so let's talk about completing the square, right? Most of you still don't know how to complete the square to factor, right? So, there's, excuse me. Here, let me try a few different ones on for size here. Factor if possible. Via completing the square. All right, so start us out somewhat easy. 2x squared plus 100x plus 40. 40, is that what I want? Do you think about this for a second here? Yeah, plus 40, that should be fine. So this one's actually harder than anything on the quiz, right? So this one has an extra step. The extra step here is to factor 2 out. Right, so I'll do this one. If you want to try to work ahead of me, see if you can do it by yourself before I do it, go for it. The other one we'll try out is x squared minus 30. Well, 30 is too big. Let me do something a little smaller. 26x minus, I don't know, 3. All right. Both of these we're going to use completing the square to factor, okay? Okay, so the first thing with completing the square is if you've got a coefficient in front of the x squared, you got to factor it out. Right? That's not too bad here because I can factor 2 out, right? Are you guys with me so far? I hope. Now, how do we complete the square? What do we do? Same thing every time. Once you have it, so x squared is sitting on its lonesome. You take whatever is the coefficient of the x term, you divide by 2, and you add that, in this case, 25 to x, right? Now, when I do that, to be fair, I have to subtract the square of whatever number I put here, right? So subtract the square. subtract its square, which in this case, 25 squared is 625. All right, so fine. That's not all, right? The first two things I just wrote there, those are identically equal to these two terms right here, right? So if you square that out, FOIL it out, as you guys like to say sometimes, you get back the terms underlined in red. Of course, I still have that plus 20, right? I still have the plus 20. Close my parentheses. Okay, so what do I got? I've got 2, big parentheses, x plus 25, quantity squared, minus 620. Right. I did that wrong. Can you guys do the math for me? 600. How do I get 620? I was like, you guys looked. I looked back and there were faces that looked like I'd insulted your mother or something, you know? I mean, I don't know your mom. She might be nice. I don't know. What am I saying? Your mom is nice. Of course she's nice. She's. Let's not say anything about your mom. There is a vast literature about that, though. Not your mom specifically, but the general concept of a mother. People have made their career about this. Is there like a Jeff Foxworthy of mom jokes? Like Jeff Foxworthy's whole thing was like redneck jokes, right? Is there like a Jeff Foxworthy of just your mom jokes? Like their whole act is just like your mother jokes? No? I haven't run across such a person, but it'd be interesting to try. I'm not sure there's enough in that genre to support a whole act. All right, so what now? We've got to look at 605. We have the difference, right? So the thing is, when you see this, look at this as the square root of 605 squared. So we can fall back on our a squared minus b squared is a plus b times a minus b, right? And so think of this as like a, think of this as like b, and so lo and behold, we have factored it. Next step here, 2x plus 25 plus the square root of 605, x plus 25 minus the square root of 605. That is how you can factor with completing the square. Right? I said if possible, right? And what I mean is, if possible, to be more complete in my language here, over the reals. Right? So I had a problem on your quiz, factor completely over the reals, right? So here, we could factor completely over the reals because, of course, the square root of 605, that's a real number. It's ugly. Whatever it is, but, you know, I don't know, 24.3 or something. Who knows? How about the other one? Can you guys complete the square on that? What does it look like? So this one's easier, right? Because we don't have to factor the 2 out. We just have to take half of 26, which is 13, right? You square that thing. We have to subtract the square of 13. The square of 13 is 169. So minus 169 minus 3. So what do we have? We have x minus 13 squared minus 172. Think of that as 172 squared is 172 squared, and you're done. I was trying to make these examples different, but unfortunately, it's kind of the same example, right? Can I try another? Let me try another. Yep.
That number, like 172, will that ever be, that number ever be the square root of 25?
It could work out. Yes, it could work out to something nice. I'll show you one of those. Well, before I will get to that, let me show you one where it doesn't work out, just real quick here. If I had x squared plus 6x plus, 20, right? This would be x plus 3 squared. I have to subtract 9. I add the 20. What do I get? X plus 3 squared plus 11. if when you complete the square, right, you end up with plus a number, what does this mean? So this is prime, right? In the sense that you cannot factor that, right, without using complex numbers. Okay? I will ask you some questions on the, I asked you questions on the quiz where the solution is a complex number, right? But I have not asked you to factor using complex factors, right? Yep.
How do you know when to use completing the square versus like quadratic formula?
Well, you definitely want to use completing the square if the instructions say use complete the square. That was easy, right? That's easy. But I don't know. I mean, it kind of depends on how ugly it is. I mean, you can always complete the square. Completing the square will build the quadratic formula for you for a specific problem. So I'm going to come back to your question when I'm going to project the solution here in a minute, and then we talk more about your question, because there are some places on the solution where it kind of naturally comes up. That's a good question. I mean, that's the fundamental question, is like, when you're deciding to factor something, right? Do you just factor using just plain factoring, right? Like just look at it and see it? Or do you use completing the square, right? And so I would say the first thing I try is completing this. First thing I try is just plain factoring. If I can factor it, great, it's done, right? And if that doesn't work, then I fall back on completing the square. And then in terms of solving an equation, again, I use factoring to find solutions first. If that doesn't work, I complete the square. I use a square root property to find the solution. If that's still looking kind of complicated, then I fall back on the quadratic formula. Now, a lot of you, probably half of you, have tried to solve problems using the quadratic formula, and you were not careful. Like, you kind of used it, but you kind of didn't use it. Like, there's a division by 2a in the formula, but you've just divided like one of the terms, but not both of them by the 2. And got the wrong answer. Like, that happened to a lot of people. So your question was about, will it ever not be something will it ever be something that you can actually take the square root of and get a whole number again, right? I mean, a good question. Here's one. 6x squared plus 19x minus 7. Now this one, of course, we could just factor, right? But let me just walk through it with completing the square. So to complete the square, I factor the 6 out. Oh, this one's horrible with completing the square. Let me not do this one. This one's easier. This one's way easier to do the other way. Let me not waste our time. The example in the other quiz was better. This one's bad for this. This one will just, you guys tell me how to do it. Let me find the other example here. I did it earlier today, so I know it. This one's better for completing the square. As an it's a better example. The fractions are not as ugly in this one. So the top one, that one you can just factor, right? To get this, you want a 7, so you need to use 1 and 7, right? So you either got to think about putting a 1 here, or a 7 here, or a 7 here, and a 1 here, vice versa, right? But you've got this 19. How do you get 19 from, like, 3 plus 14 is what? 3 plus 14 is 17. That didn't work, does it? So what if we put the 7 here, right? And we put the minus 1 over here. Does that work? See, then I've got plus 21, right? Minus 2. There it is. So that is definitely the right way to factor that. Completing the square would not be, you know, the best way there. But you do have to see it, right? So suppose you don't see it. Something like this, there's a lot of different ways to factor 8, right? 1 times 8, 2 times 4. There's a couple different choices there, right? So let me just, instead of doing it this way, let me walk through how we would do completing the square here. So I factor the 5 out. I've got x squared plus 14 over 5, x plus 8 over 5. All right? So you guys help me out. What is half of the coefficient of x in this one? What's half of 14/5? Half of 14/5 is 7/5, right? So I do 7/5 squared. Now to be fair, I have to subtract the square of the number I added, which is to subtract 49 over 25. All right? The square of 7/5 is 49/25. What I have written there is identically equal to what I have right above here. So these two terms are those two terms. I still have the plus 8/5. Now we want to add 8/5 to the, we want to turn 8/5 into a 25th, right? So we can add it. So let's do that. What do you, to convert this to 25ths, how many do I have? I got 40 25ths, right? So I multiplied that fraction by 5 over 5 to get this. Now we can add them, yeah? So we've got 5, x plus 7/5, quantity squared, minus, well, apparently minus 9 over 25, yeah? Now, so this is that place where you're asking me, is there ever one where we can actually take the square root? This one. See, if I take the square root of this squared, what's the square root of 9 over 25? Yeah, exactly, it's 3/5. So I'll write it out again so you guys can see it. And what are we going to do? We're going to use, yet again, the difference of squares formula. So we do 5, x plus 7/5 plus 3/5, x plus 7/5 minus 3/5. All right? What's 7 plus 3 is what? 10, so we've got x plus 10. What's 7 minus 3? 7 minus 3 is 4, so we have times x plus 4/5, yeah? So what would have been the clever way to factor this would have been what? Instead of completing the square, you could just look at the original one and write it as what? This is actually equal to? See, x plus 10 times what? If you multiply this 5 over here, you get 5x, right? Plus 4. So what is easier? Writing what I wrote in red or completing the square? I mean, of course, what I wrote in red is easier, unless you don't see it, right? If you don't see it, then completing the square is an algorithm. You can fall back on it if you understand it. Yeah. What did what? Oh, have I done that wrong? 10/5. And 10/5 is not 10, is it? Thank you. So what should that be? 10/5 is otherwise known as 2. And probably this should be a 2 as well, right? Checking the answer, 2 times 5 is 10. 10 plus 4 is 14, which is what we had here. Thank you. Very helpful. I think I have said my piece about completing the square. I've said what I said. All right, so I do want you to learn it. It is on the test. Please, if you haven't learned it yet, please work on learning that. Let's see here if I can get this thing to work. This is your final chance to top at. You have about 10 seconds. Boop, 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 boop. Well, so yeah. Uh-huh. Okay, there we are. So the question was asked, when do you know to use completing the square? When do you know to use, the quadratic formula? I would say, for me, a good example where quadratic formula made more sense to me in terms of a method was, well, like this one, for example. Listen, like the difficulty of the quadratic formula is the difficulty of completing the square. They're really the same thing, truth be told. The way we derived the quadratic formula was completing the square. So, but here's a place where I used it. Just because, completing the square involves, like, you'd have to have x plus a half squared. I'd end up subtracting a quarter from 24. Like, I could do that, but I just used the quadratic formula. And so I did that here. B is 1, b squared is 1, of course, minus 4ac. And so you get minus 1 plus or minus the square root of 97 over 2. Those are not integers, therefore. Now some of you asked me, what are successive integers? Successive integers are like 1, 2, or 3, and 4. They're one right after the other successive integers. We had a homework problem. We did an example in class like that. Now, this problem is not on the test. The reason for that is you guys have found ways to solve this problem without algebra, and I can't really count it wrong. So some of you are just like, well, if you think about whole number factors of 24, none of them are successive, so it can't be the case. It's like, you're not wrong, but it's not what I wanted. So I can't put that on the test because I can't grade it. But it was a problem in your homework, which is why I was on the quiz, The other one that, where'd it go? The other one, come on, I'm sorry guys. Where'd that problem, I cannot find it. Let me go to a different view. I'm keep skipping past something I'm trying to find. So just a reminder, I've said this, but I'll say it again. Where is, all right, fine, I'll take it. Words. You either took version A or you took version B, right? If you haven't done the other one, you should. That's a good thing you can do to study, right? Make sure that you can do the problems on the other version of the quiz. They're not quite the same, right? The test is some kind of in between, right? Pretty similar format. I'm going to, add some sentences. Like one of the sentences I'm going to add on problem 4, it's going to be something like, find all solutions of the following quadratic equations, simplify your answers for full credit. See, because some of you have kind of half used the quadratic formula and not simplified the answer. I don't usually care about that, but on this problem I do. I want answers to be relatively simple as they can be for this problem. So like this one ends up looking like that. This one, so here's the one I was talking about. A lot of you guys have managed to divide one or the other of these by 2, but not both. A significant portion of class did. Coming back to your question again about the quadratic formula, I think this one maybe is a good problem. I used completing the square to solve this, see? See, I completed the square here. I ended up having to subtract, the square of 5/4, which was that, which gave me this, kind of ugly addition of, so, the trouble of doing this arithmetic is exactly the trouble of using the quadratic formula. This one I might as well use the quadratic formula. It would have probably been easier. Here's an example where quadratic formula would have been a good idea. It's kind of funny that the work here is so ugly, isn't it? And yet the answers are like pretty whole numbers. It's a weird example in that sense. It's hard to come up with something like that if you try. So let me stop. Are there any questions about a particular problem? I'm going to focus our attention towards a couple things that people had trouble with. But you can jump in and we can focus elsewhere if you have a question. These solutions are posted in Blackboard. They're there under like module 4, under the, I forget if they're under the learn or the apply. I think I put them under learn. You'll find them. This PDF is posted in Canvas. It's been there. Did I say Blackboard? I didn't mean to. It's been there for days now. Anyway, so here, a lot of you are just squaring. Like your next step is x squared minus 15 minus 2x equals 0. So you're just squaring terms individually. You cannot do this. It is not true. I need to adjust that camera because so do you understand what I'm saying? You can't just take a plus b and square it, right? It's not equal to a squared plus b squared. That's not how squaring works, right? There is a middle term. There is a plus 2ab in the middle. You have to multiply it out. There are 3 terms when we square. When we square a sum, we don't just square each term individually and that's it. That's not all there is. There's more. There's the middle term. For that reason, you don't want to square the problem as it's stated. You must first isolate the radical. If there's a radical in the problem, isolate the radical. So I isolate the radical. Now I square it. Quadratic equation, factor, solve. Then at the end of that, you have to try them out, because when you square the equation, you can be adding solutions. So we have to check our answers, and it turns out that the minus 5 is not a real solution. It's extraneous, but 3 works, so the solution set just contains 3. I did not take points off here if you just wrote x equals 3 as your solution. I'm not fussing about that. I will fuss about not using interval notation where I say to use interval notation. All right? If I say use interval notation, you must use interval notation. More on that later. This here, the third power, you just cube both sides to get rid of that. Minus 2 cubed is minus 8. Again, the quadratic equation. We can factor it. We can solve it. Interesting fact, when you cube an equation, that doesn't introduce extraneous solutions. I don't even need to check it. All right. Even powers, like if I square it or if I was to quadruple it, I could introduce solutions that are not actually solutions. Part C, notice that this is either going to be minus 2 or 2, which then gives me minus 1/2 or minus 5/2. Some of you got these answers on the other version of the quiz. What's the difference? The other version of the quiz, instead of having a 2 there, has a what? Negative 2. Can you solve absolute value of 2x plus 3 equals to negative 2? You cannot. The answer is no solution. So everything else you did was just, I mean, if you found minus 1/2 and minus 5/2 here, they're both extraneous. Yeah.
So if you have an equation like that and it equals to a negative number, it's just no solution.
Right. If we have absolute value equals to a negative number, no solution. If we have absolute value, we're solving an absolute value less than a negative number, no solution. So those are 2 to watch out for. They're both on either quiz A or quiz B. This is the other quiz. This one had a rational function, so you multiply by x minus 6. Again, it gets you this quadratic. That quadratic, this is the hardest factoring problem, I think, on the whole quiz, personally. That I didn't see this without, it took me a while to see that. But anyway, you do, that's how it factors, and so you get 18/7 or minus 3. I think this problem's hard relative to other problems on this quiz. This one, again, isolate the radical. Isolate the square root of 2x, gives us x minus 4. You square both sides. When we square x minus 4, we get x squared. Notice the minus 8x. A lot of you guys are missing that. When we square a sum of 2 things, you have to multiply it out. There will be 3 terms because we collect the like terms in the middle. In this case, that minus 8x is there. Then put everything on one side, you factor, you get a solution. Well, you get 2 solutions. You get 2 and 8, but only 8's legit. 2 actually doesn't work when you plug it in. So again, we have to check our answers here because we squared the problem. Whenever you square the problem and go on, at the end of it, you need to go back and check. All right? I think most of you don't understand the zero factor method yet. We've spent a lot of time on this in lecture, but it just hasn't quite sunk in for a lot of people, right? Now, there are a subset of you who got this right, but there's a lot of you who got it wrong. Everybody can get this problem right. You just need to figure out what it is you're doing wrong. If you've got a paragraph of stuff, x less than this, x greater than this, there's like a paragraph of writing, you're doing it wrong. You need to write down the number line, identify the zeros, and assign pluses and minuses. You go from there. This is the method, all right? So try it. Don't give up on the method. You can do it. It's not that bad. It really isn't. So I have -7, -1, and 5/4 are what make these 0. That gives me the critical numbers. I have to put them in order. Some of you found a way to put these out of order, and then that made your answer kind of look out of order. Maybe that didn't have anybody in here. So here's a fun fact. If all of the coefficients are like positive on the x, just think about it. If we put in like x is 1,000, it would definitely be a positive number, right? That'd be like 1,000, 3,000, 4,000. The product of that is definitely a positive number, right? So that shows me that way over to the right, I got pluses. Once I know that, I can take these pluses and then go plus to minus, minus to plus, plus to minus, because again, these are all odd powers. Once I have that, I look at it. I'm solving less than or equal to 0, right? So I'm looking for minuses. They're here and there. So I get minus infinity to -7, and also -1 to 5/4. And all of the endpoints are included here because we're looking for equals to 0, and there's no division by 0 in this problem, right? Let's contrast this problem to the problem in the other version of the quiz. The other version of the quiz, you guys were up against this one. So the other version of the quiz had the somewhat tricky x plus 6 less than -4 question here, right? Answer, no solution, right? Here, the critical numbers are what? -7, 6, rather 3, and -1, right? This time, I've got some squares. So if I've got a square, that means that the sign stays the same as I go across those critical numbers. You think of it as kind of like bouncing off the x-axis if you want to think about it graphically. Foreshadowing comment, okay? But so if I think about plugging in like 0 here, that's a nice one to start with. I got a 7, I've got a 36, I've got a -27 from that, and I've got a 1. So I've got plus, plus, minus, plus. The net is a negative if I plug in 0 here, so I get negatives. Then going across 3, well 3 is this x minus 3 cubed term here, right? So I'm going to flip from minus to plus going across 3. In contrast, 6 is x minus 6 squared, so I stay plus going from there to there. -1, this is from this x plus 1 squared, so I stay minuses there. And then when I get to the -7, it's a linear term, it's a first power, so I flip from minus to plus, right? So I'm using the plus minus rule. If you don't like the plus minus rule, you can plug in a number here, 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 and here, check the sign of it, assign the pluses and minuses, all right? You are going to have to stop and calculate 5 numbers if you do it that way, though, right? You can do that if you don't like this plus minus theorem I'm using. All right, so now that we have the sign chart assembled, we're trying to solve less than or equal to 0 again, right? So I'm looking for minuses, right? So that's why I put down -7 to -1, union -1 to 3. Now, why don't I include the -1 here? I had to exclude it because, see that? -1 gives me division by 0, so I have to rule it out, all right? And then, okay, what else? 3 I have to throw out as well because 3 would give me also division by 0, which we do not want. So we must throw out 3, we must throw out -1. We're looking for equals to 0, so be careful. We should also throw in -7 and 6. Now we already got the -7 there, right? But the 6 is not included yet, so I have to union with the set just containing 6. If you had all of this right here correct, but you just forgot the union with the 6, I'm sympathetic to that. I didn't take off a lot of points, right? But let's go to the last page here. So greater than absolute value, remember, is we solve less than -2 or greater than 2, and that gives us two separate inequalities, which either gives me that or that. I take the union of them for the solution for the greater than problem. All right, this one, plug in 2. So we get square root of 2 times 2 plus 1, which is 5. If you're doing a bunch of work here, I don't know what you're doing. You know, don't make this complicated. This one here, again, don't make it complicated. The question is, what's the domain of the function? The question is, where does the formula break? This formula breaks at 4. So we must throw out 4. So we take minus infinity to 4, union 4 to infinity. That's the domain of this guy. That's all there is to it. The other version, see the other version had x minus 2 over x squared plus 4x plus 5. Now some of you incorrectly factored that to say it's x plus 1 times x plus 4 or x plus 5 or something. It doesn't factor though. This, if you complete the square, you've got x plus 2 squared plus 1. So this is actually a prime polynomial. It's never 0, which means the formula is always fine. So this formula never breaks. The domain is everything. Completing the square allowed me to see that. We haven't talked a lot about this, so this is a bit of a challenge problem compared to some other things, right? But again, the greater than problem, f of 2, this time we just square it, add 7, we got 11. Let's talk about the last problem. Well, the next to last problem. Here, for you who had this version, we go minus 8, right? Down here, the dot, f of minus 8 is equal to minus 4. The domain is the allowed inputs, right? So the domain, we go from minus 8 all the way over here to 4. It's not included. And then we start up again here at 6 and all the way over to 8. Those are the x values. The range, we go from minus 4 here all the way up to 4. Minus 4 is included, but 4 is not. And then we jump up here to 6 to 8 again for the range. These are y values. The range is based on y values. Some of you just gave me like a list of numbers here. I don't even know what to do with that. You must put your answers in interval notation. This is interval notation, all right? Here, right, some people get it right. Some people got it kind of half right. The main thing here, of course, is you need slope 3, right? To find the line with slope 3 that goes through the point minus 2, 10, I use point slope. So the point was 10 minus 2, so I do a 10 here and a minus 2 over there. My slope is 3. That's the formula. So the other one was perpendicular, right? So this one's a little bit different looking. So this one, f of minus 2 is what? So some of you told me it's 2. That's not right, because that is not filled in there, right? Minus 2, the dot's down here. That makes f of minus 2 equal to minus 6, right? And let's see here. In terms of x values, you start at minus 8. And we've assigned everything. Still assigned it at minus 2. We keep going all the way over here to 2. So the x values go from minus 8 to 2, and not included both the endpoints. And then we pick up again here at 4, which is not included because of that circle. And all the way over here to 8. So that's the domain. And the range, if you look at it, it's got a y value from minus 6 all the way up to 8. Nothing's missing. If you look, there's something covering every y value between minus 6 and 8 included. And here, perpendicular means negative reciprocal. And again, I use point slope, this time with the point minus 1, 4. So I do 4 minus 1/3 x minus 1 to give me that equation, which simplifies to that. This was right, that was right. I would count either right. So, any questions? You do get a formula sheet, yep.
Is there a way for us to see like our past homework? Or like,
I think you can look at completed homeworks.
okay. Because I was trying to find it and it like there was nothing there. But I
It doesn't
couldn't-
let us. Not after the
It doesn't let you see it after the due date?
Oh, yeah.
Really? Hmm.
Because I was going to go back and like go through those, but I couldn't find like, I didn't think it was.
Well, in the meanwhile, while I'm trying to fix that, I would suggest looking, in the book, there's problems at the end of sections, so look at those, Or also the lecture, of course, you know, we can look at lecture examples.
Is it still just one page?
Yeah, one page of notes, front and back. You can use the same one if you want. I gotta turn that off. Did you already turn it off?
Oh, no. The button on the other side.
Yeah, it's on the other side. That's okay, I'll get it.
Are testing pieces cumulative, or is it like just based on what's been covered in the tree?